Example 1. Triangle ABC has vertices A at -3, 2, B at -2, 4, and C at 2, 1. Graph triangle ABC and its image after a rotation of 90 degrees clockwise about C. So in this case, because we are about C, that means C is our center of rotation. C is our center of rotation, but C is not the origin. So we cannot apply the rules directly. So we are going to have to use translations in addition to our rotation rules. The first thing we need to do is graph triangle ABC. And you can see triangle ABC graphed on this coordinate plane. The second step is that we need to map the center of rotation to the origin. So to map the center of rotation to the origin, we need to translate point C to the origin, and then translate the vertices of A and B using the same rule. Since point C is located at 2, 1, we have to translate it back to 0, 0. So we have to subtract 2 from the x coordinate and subtract 1 from the y coordinate. So we are going to apply this translation rule to point A and point B. When we do that, we take -3 and subtract 2 to get -5. We take 2 and subtract 1 to get 1. So A is now located at -5, 1. Point B is located at -2, 4, so we have to translate it by subtracting 2 from the x coordinate, which means we end up at -4, and then subtracting 1 from the y coordinate, which means we end up at -4, 3. And since C is what we're used to find this translation rule, C at 2, 1 goes to the origin 0, 0. Step number 3 is to use our rotation rule for 90 degrees clockwise about the origin to find the new location of our translated points. So the new location of A is going to be 1, 5, because we switched the x and the y coordinate and we took the opposite sign of the x coordinate. B is now located at 3, 4, because we swapped the x and y coordinates and we took the opposite sign of our x coordinate. And 0, 0 is still the same because that is our center of rotation. The fourth step is to map the center of rotation to its original position. To map the center of rotation to its original position, translate the point at the origin back to 2, 1. Then translate the remaining vertices using the same rule. So in order to go from the origin back to the point 2, 1, we have to move 2 units to the right and 1 unit up. So our translation rule is xy translates to x plus 2, y plus 1. So A, which was located at 1, 5, now translates to A prime, which is 3, 6. B, which was at 3, 4, now will translate to 5, 5. And C, which was our center of rotation, it will now translate to 2, 1. Let's check your understanding. So we have triangle PQR. It has vertices P at 2, 1, Q at 2, 4, and R at 5, 1. Graph triangle PQR and its image after a rotation of 90 degrees counterclockwise about Q. Teachers, please pause the video now. So the first thing we have to do is map the center of rotation to the origin. So we have to take Q and translate it so that it is now going to be on the origin. So if Q is at 2, 4, we have to subtract 2 or move to the left 2 and go down 4 units to get back to the origin. So we apply that same rule to P and R. Step 3 is to rotate 90 degrees counterclockwise about the origin. We're going to use the rule XY rotates to become negative y comma x. So point P, R, and Q have been rotated 90 degrees counterclockwise about the origin. Finally, we have to map the center of rotation to its original position. So since point Q is on 0, 0, and it's supposed to be on 2, 4, we have to go to the right 2 and up 4. So we're going to apply that transformation to points P and R. So in the end, point P, the final image point for point P, is at 5, 4. The final image for point R is at 5, 7. And the final image for point Q is at 2, 4. And you can see on the graph that our triangle has been rotated 90 degrees counterclockwise. Talk about it. Did you correctly find the coordinates for Q prime, P prime, and R prime? If not, do you know where your mistake occurred? And can you correct your mistake now? Teachers, please pause the video to have students share. Kendrick is working with a team in his social studies class to create a new country and its government. Kendrick is responsible for creating the country's flag. He is using geometry software to design the flag on the coordinate plane. Kendrick wants to test the positions of the stars by rotating them as a single object. Describe the rotation that will map the star design onto itself. So if we look here at the star designs, it looks like those two stars are touching at the point 11, 2. It appears that this star on the right is flipped around or rotated around that point 11, 2, 180 degrees to create this star here on the left. So let's see if that might be the rotation that will map the star design onto itself. The left star is upside down when compared to the right star. So this appears to be a rotation of 180 degrees counterclockwise. If the two stars are rotated about the center of rotation at 11, 2, where the two stars intersect, then the star design will map onto itself. Example 3. Describe the rotation using coordinates. Triangle ABC has vertices A, -3, 2, B, -2, 4, and C, 2, 1. Its image has coordinates A', -2, -3, B', -4, -2, and C', -1, 2. Describe the rotation using coordinates. So the first thing that I'm going to look for is if there is a pattern in the way that these coordinates have changed. So if I look from A to A', I notice that -3, which is the x coordinate in point A, is now the y coordinate of point A'. And 2, the y coordinate of A, is now -2 as the x coordinate of A'. I'm going to check to see if that happens in B and B', and C and C'. So yes, it appears that in A to A', B to B', C to C', my x coordinate and my y coordinate switch places, and what used to be the y-coordinate becomes negative, or the opposite sign. So which rule is that an example of? Well, my x and y switch places, and my y-coordinate becomes the opposite sign. So this rotation is a rotation of either 90 degrees counterclockwise or 270 degrees clockwise. And the rule that I'm going to write as coordinates is xy transforms to be negative y, comma, x. Here's a check. Triangle ABC has vertices A, negative 3, 2, B, negative 2, 4, and C, 2, 1. Its image has coordinates A prime, 2, 3, B prime, 4, 2, and C prime, 1, negative 2. Describe the rotation using coordinates. Teachers, please pause the video now. Again, we're going to pull up our rules and figure out how we have changed from A to A prime, B to B prime, and C to C prime. So if I look at C to C prime, it appears that my x and y have switched places and the x value has taken the opposite sign. So that appears to be my 270 degree counterclockwise rotation, or my 90 degree clockwise rotation. So my rule using coordinates would be x comma y to y comma negative x. Did you get this correct? If so, congratulations. If not, do you understand where you made your mistake? This is the exit ticket. Please have the students complete the exit ticket and turn it in before they leave. Go ahead and pause the video now.